All right, so we are entering trigonometry, better known as circular functions, and you'll find out why it's circular in just a second. So you learn the quadrants are labeled as such. You learn that this is 1, 2, 3, 4. Well, why did somebody decide to go counterclockwise? Why didn't we go clockwise? That's how the clock goes. Well, we're going to have to take you back to the Greeks. Well, the sun rises in the east and sets in the west. And wow, look what the Greeks saw. So here's our sun rising. And we know that when it's noon, straight up, there's no shadows. And then as the days gets longer in, the shadows get longer. And then this lovely program does not let the sun go below, but this would be nighttime when the sun is on the other side of the earth. So let's look at this a little closer. We have our sun. We have something here that's casting a shadow. So that's called over here, this person who made this program called it the stick. And they gave it a length of 1. Then there's a shadow, which is on the ground here. And then we have the length of the hypotenuse. And you find out how these are all related. Something else that's happening is there's an angle being formed. A 30-degree angle here about roughly. And then as we get closer and closer to that 90-degree, if we can get there, probably not. There's no shadow, and then we keep going back here. Notice how the shadow length is getting longer and longer. But this is the basic reason why quadrant 1, quadrant 2, and then we would go down 3 and 4. So there, that solves the mystery of why the quadrants go as such. All right, what I want you to do right now is take time, and I'll make this smaller so it fits on the screen, is take time to write all these definitions down. Pause it if you have to, because I'm going to continue to talk right now. You need to learn these 4 words. We're going to use them throughout trigonometry. Standard position. An angle is said to be drawn in standard position if its vertex is at the origin and its initial ray points along the positive x-axis. What does that mean? Well, basically this is what we did. We took the sun and we made it into the x and y axis. And we're going to change those names later when we do trigonometry. But then we drew on them an angle. An angle is said to be in standard position if its vertex is at the origin, so there I am at the origin, the initial ray points along the x-axis in the positive direction, and then we have it opening up, and then we're going to open it up to whatever distance, make it rotate around. So that is called a standard position. We have positive and negative rotations. A rotation is said to be positive if the initial ray is rotated in a counterclockwise to the terminal ray. So in other words, basically the initial ray is going to stay there, and then we're going to take this ray and we're going to be moving it. This ray is then called the terminal ray because it terminates somewhere. Terminate means to end. So this terminal ray is going to end somewhere. And then this is the initial ray. This is where I started. And then I measure the distance between them. I can measure it in a positive direction, which is what I just did right there. Or I can measure it in a negative direction, which means I can measure this way. Both ways we end up in the same spot. Just think about driving somewhere. Sometimes you take the long way, and sometimes you take the short way. Either way, you end up in the same spot. A coterminal angle. Any two angles drawn in standard position that share a terminal ray. So we're going to go back to this picture right here. This green angle and this pink angle are coterminal because they end at the same spot. So let's say X was 120 degrees. Whoops, sorry, I should do that in pink. Let's say this one was 120 degrees, then the coterminal would be 240. And then we put a negative in front of it to represent the fact that we moved in a negative direction. We're going to practice this. This is what today's lesson is all about. And then we have the reference angle, the positive acute angle formed by the terminal ray and the x-axis. That is this angle right in here. All right, so let's look at this. So we have here a circular protractor, which best represents the sun. It goes around and around, and notice it comes back to, well, shockingly, 360 degrees. So we're going to just take an angle here, and let's just start off with a nice easy one. Let's start off with 60 degrees. We're going to pop that out, and then we're going to shrink this down so I can have some room to play with this. And here is our lovely 60 degrees. Now, first of all, let's review some of our words. We know that this is the initial ray because that's where our angle started. We know that this here is the terminal ray because that's where we ended. And this angle is 60 degrees. It is right now in standard position. Right? Standard position told us angle is said to be drawn in standard position if its vertex is at the origin. Just got a text message. Oops. And its initial ray points along the positive axis. So we've got that. It's at the vertex is its origin. Sorry, the vertex is at the origin, and the initial ray is indeed pointing along the positive x-axis. Did we do a positive or a negative rotation? Well, we did a positive rotation. If there were a negative rotation, that means I would have gone this way. And that would have been a coterminal angle in blue. And its measurement would have been negative 360. Get it? Because if I took the absolute value of 300, negative 300, and 60, we would get 360. So therefore, our positive and negative rotations, their absolute value should always add up to 360. Now I have some other coterminal angles too that I want to talk about. This is kind of what's cool. Angles like this can go on and on and on and on and on, and then I decide to stop. That's the way the old radio dials used to be in cars. Or actually, no, that's the way they are now. The old radio dials used to stop. Now the radio dials spin and spin and spin and spin, right? You go into a car and there's no way that you can stop spinning that radio dial to make the music louder and louder. Now, of course, your radio has a maximum volume, but that dial that's turning never stops. And that's a point because one of the things that cars used to be brought into to be fixed all the time were radio dials because that's what kids play with the most. And that's what kids broke the most on cars. So a feat of engineering decided, well, let's combat that. So in other words, I could have an angle that I start here, I go around, and then I stop there. There, I just did a coterminal angle of 360 degrees plus the final 60 degrees. So I did an angle of 420 degrees. That's still coterminal with my original 60 degrees. Now what about that reference angle? The positive acute angle, so it's got to be positive, it's got to be acute, formed by the terminal ray and the x-axis. Okay, well where's my terminal ray? Right here, and the x-axis right there. So what I do is I drop generally from the tip down. and I just formed a reference angle. And in trigonometry, we use Greek variables. So we'll use alpha, beta, theta interchangeably with x and y. So we generally call this theta as that reference angle. And in this case, the reference angle here happens to be 60 degrees. Okay, so we're going to make one more rotation. And this time let's go into a really kind of freaky one. Let's go here to 250 if I can get that. Boom. All right, let's get that out. Shrink this down again. And bring our 250. Now notice what this little program does. It shows us which way we measure. All right, so it is in standard position. We have our initial ray pointing in the positive x-axis, and then we have a terminal ray. We have a positive rotation of 250 degrees. And then if we wanted to look at the negative rotation, well, we think you can do that by now. It would be negative, let's change that color. Let's say negative, and you can figure it out, 110, because it has to, absolute value has to add up to 360. So if I went this way, that's a negative rotation of 110. It's also a coterminal angle. In other words, I can get to this spot right here by traveling positive 250, or I could go negative 110. I can also go, oops, oh, I didn't realize it would erase that line. Learn something new every day. It also can be obtained by going in, let's see, I can go in the opposite direction. I can go backwards 360 degrees. I can go backwards another 360 degrees, which makes that 720, and then I can decide to stop there. Well, that's another coterminal angle. So I went 720, I went 2 full circles, and then another 110 degrees, so I went 830 degrees in the negative direction. And either way, I stopped. Now you're thinking, why would you do that? You passed it twice. Just telling you that can be done. Now, here's the reference angle part. That's the part that tends to mess people up when we get outside of the first quadrant. So remember, our reference angle is the positive acute angle formed by the terminal ray and the x-axis. All right, so here is my terminal ray. Here is my x-axis. So I want the angle that's formed in between those, and that is my reference angle. And indeed, that is going to be acute, because it's definitely less than 90 degrees. We'll call it theta. And can you figure out how big theta is? Well, let's see. The whole thing was 250 degrees. I'm only looking at this purple section right here, which means I'm ignoring this part of my 250. Hey, and guess what? That 250 part I just ignored was 180 degrees. So if I subtract 250 minus 180, you got it. That reference angle right there happened to be 70 degrees. We're going to do one more real quickly, and let's look at, well, let's look at that one. Let's look at a 330 degree angle. Come on. There we go. Pop it out. Get rid of this. Bring that 330 back over here. All right, so hopefully we realize it's in standard position. We got our positive initial ray. We've got our terminal side. All right, positive and negative rotation. So we rotated this positive 330 degrees, which means we could have gotten to the same position by going backwards negative 30 degrees, because 30 and 330 makes 360. Coterminal angles, once again, coterminal means how can I get to this terminal side different ways? Well, I could go around once, twice, 3 times, 4. Now let's not go 4 times, let's go 3 times, which would mean 360 times 3, which is 1080. And then I went that final distance of not a complete circle, but another 330 degrees. So I could have gone 1,410 degrees and ended up in the same spot. And then finally that reference angle. The reference angle is what I really want you to understand, because that's what's going to be the whole crux of trig. I go from the terminal side to the x-axis and I measure this angle in there. Well, how big is that angle in this case? Well, that angle is going to be 30 degrees.